Okay, this is the second half of your worksheet, and it says to simplify. One thing that you want to always remember is that you have to have like radicals in order to add or subtract. Like radicals mean, for instance, this is a radical 24 and this one is a radical 27. Are those the same? No. So earlier in the chapter, you probably learned how to simplify just simple radicals like this, where you find two numbers, one of which is a perfect square, to go ahead and break down 24. So that's what I want to do here, because I can't do anything with these because none of the numbers under the radicals are the same. So what I want to try and do is get them so that they have a number that's the same under the radical. So what I'm going to do is just go ahead and leave the 3 out front, and I want to break down radical 24. So what you want to do is go ahead and find two numbers that multiply to give you 24, and one of them that's a perfect square. So 24 divided by 3 leaves you with 8. Okay, well neither of those are perfect squares, so let's go ahead and think about it differently. How about 24 divided by 4? Okay, 4 is a perfect square, which I know is 2, and it multiplies by 6. 6 is not a perfect square, and it can stay under the radical there. So let's see what else we can do. Okay, minus 2, radical of 27. So two numbers that multiply to give you 27, one of which is a perfect square. Okay, that's going to be 9 times 3. 9 is a perfect square, and 3 really can't be broken down any further. Okay, minus two numbers that multiply to give me a 54, one of which is a perfect square. So again, we just did 54 in the other example, but 54 divided by 9 leaves me with 6. Well, that's okay because I have a 6 here, which seems to me that I might be able to go ahead and combine those. So I'm just going to say 9 times 6 here. Okay, now we want to go ahead and break them down a little further. So I have this 3 out front, and if I ever bring anything outside the radical and there's a number in front, you always multiply. Okay, so radical of 4 is 2. So I'm going to say 3 times 2. Can I break radical 6 down? Well, no, so it's just going to stay under the radical. Okay, that's okay. It's just not simplified. Okay, so 2 times radical of 9. Okay, we know radical 9, or square root of 9, is equal to 3. So 2 times 3. Can I break down radical 3 here? No, so this is going to be radical 3. Minus radical 9 times 6. So can we break down radical 9? Okay, yes, that's going to be a 3. Again, we can't do anything with radical 6, so it's just going to stay underneath the radical. Okay, let's just go ahead and simplify this a little bit further. So 3 times 2 leaves you with 6 radical 6. Don't do anything with the radical, just go ahead and simplify it. Okay, minus 2 times 3, which is 6, radical 3, minus 3 radical 6. Okay, what two radicals here do you see that are going to be the same? Okay, I have radical 6 here. It does not match a radical 3, but I have another radical 6 here. So think of adding and subtracting radicals like combining like terms. You're not going to do anything with the radicals, but what you're going to do is add or subtract the numbers out front. I'll go ahead and group these together so that you can see that we can just simply combine them. Kind of like 6x minus 3x, except our x is going to be a radical 6. I'm just rearranging the order here for you to see it a little bit better. Okay, so because these are the same radicals here, I can simply subtract 3 from 6. So 6 minus 3 leaves me with 3 radical 6 minus 6 radical 3. That's as simplified as I can get. I can't combine radical 6 and radical 3 because they don't look alike. So just remember, this is kind of like combining like terms. So think of your radicals as variables. Okay, let's do one more. So remember, you have to have the same house in order to add numbers together. So this one's a little bit better because we do already have two that are the same. And what do you actually notice is going to happen to these? One's positive and one is negative. So what is 3x minus 3x? Okay, I hope you said 0. Those are actually going to cross out because they're positive and negative. They have the same house, so 3 minus 3 would be 0. We don't really even have to worry about doing anything else with it, but we notice that we can also break radical 18 down. So 2 times, okay, what's a perfect square times the number that's going to give you 18? I hope you said 9 and 2. So let's go ahead and break this down now. We have radical 9, so square root of 9 is 3. So 2 times 3, radical 2, or simply 6, radical 2. Okay, one more here. So this one looks a little bit different because now we're dealing with cube roots. There's really nothing different about it except you're just dealing with cube roots and cubed numbers as opposed to square roots. So can we break down the cubed root of 3? Okay, no, so we're just going to leave it like that. So we have 3 times the cubed root of 3. So we can break down this other one, and you are adding them, so you have to have the same house and the same base, or the same house and the same number underneath. So what we're probably looking for here is a cubed root of 3. So some number under here that's going to multiply by that. So we have 2 times the cubed root of, okay, let's break that down. So 81, a number that's a cubed root. Okay, I see that 3 times 27 is going to give me 81. So what I would actually start to do is I see that I have a cubed root of 3 here, so I would go ahead and multiply 81 by 3 to see if there's a cubed root that multiplies by 3 to give me 81. Okay, if you're not sure how to do this, make sure you can figure out how to do the cubed root of a number in your calculator. You'll want to look for something in your calculator that has an x and a radical here, where this is the cubed root part. Okay, so going on, we just did the cubed root of 81, so I'm just going to go ahead and write that down. Okay, so let's go ahead and simplify. I can't do anything with 3 radical 3, so I'm just going to rewrite it. Plus 2. Okay, I can't take the cubed root of 3, but I can take the cubed root of 27. Okay, the cubed root of 27 is 3. And then I'm going to have still the cubed root of 3 underneath. Then the same thing for this next one. It's just going to be 3 times the cubed root of 3. Okay, if you want to go ahead and simplify this further, this 2 times 3 right here is going to give me a 6. Okay, so what do you notice about all these houses and the bases underneath? Cubed root of radical 3, cubed root of radical 3, and cubed root of 3. So they're all the same, so I can simply add or subtract my numbers depending on the sign that's in front of them. So 3 plus 6 is going to give me 9, minus 3 is going to give me a 6 times the cubed root of 3. And this is your final answer.